MS Ramaya University of Applied Sciences.
Hello students, let us have a discussion on clamper circuits. The aim of this experiment is to observe waveforms at the output of positive and negative clamping circuits. Motivation to this experiment are the transmitter and receiver circuitry of television uses clamper as a baseline stabilizer to define sections of the luminance signals to preset levels. Clamping circuits are used in sonar and radar systems. Clampers can be used as voltage doublers or voltage multipliers. Let us understand the theory behind the experiment before conducting it. Clamping circuits are used to change DC level, that is average level of the signal, which adds or subtracts DC value with the signal. In clamping, shape of waveform remains same, only offset value, that is DC level, will change. Positive clamping adds positive DC level in the signal, while negative clamping adds negative DC level in the signal. Capacitor is widely used in the clamping circuits. To conduct this experiment, we need function generator, dual DC power supply, resistor of 200 kilo ohm, diode models either 1N4007 or BY127, capacitor of 0.1 microfarad, oscilloscope, breadboard, probes and connecting wires. Figure shows the circuit diagram for positive clamper. Construct the given circuit diagram for positive clamper on breadboard. Oscilloscope and function generator is connected to the breadboard using probes. Set an input signal in the square waveform of 1 kHz frequency and 8 volt peak-to-peak amplitude in the function generator. Apply this signal as input. Measure the input and output using digital oscilloscope by connecting it with the circuit with the help of probes. Note down the clamping level at the positive cycle with reference voltage at 0 volt and 2 volt. This shows the experimental result of positive clamper. Figure shows the circuit diagram for negative clamper. Construct the given circuit diagram for negative clamper on breadboard. Oscilloscope and function generator is connected to the breadboard using probes. Set an input signal in the square waveform of 1 kHz frequency and 8 volt peak-to-peak amplitude in the function generator. Apply this signal as input. Measure the input and output using digital oscilloscope by connecting it with the circuit with the help of probes. Note down the clamping level at the negative cycle with reference voltage at 0 volt and 2 volt. This shows the experimental result of negative clamper. Limitation of the setup is that we cannot apply DC power supply more than 15 volts as dual DC power supply available in lab has its maximum range of 15 volt.
Hello students, name of the experiment is clamping circuits and aim of the experiment is to observe the output waveform of a positive clamper circuit and negative clamper circuit and to observe the positive clamping level and negative clamping level. Components used for the experiments are function generator, dual DC power supply, digital oscilloscope, probes, capacitor having a value 0.1 microfarad, diode, resistor having a value 200 kilo ohm, breadboard and connecting wires. Let us start the connections for the positive clamping circuit based on the given circuit diagram. As per the circuit diagram, we will start connections from a function generator a function generator is connected to capacitor. So to connect a function generator, I will take a probe, connect it to a function generator. Now this probe is connected to function generator. It has two terminals, red is positive, black is negative. According to the circuit diagram, a positive of a function generator or a input voltage is connected to capacitor. So this is a capacitor. I will take this capacitor, connect in a breadboard. This is the positive of a function generator, which is connected to capacitor one end. So take a wire and connect to capacitor one end, and this is the negative of a function generator, which is connected to the ground. So I will take a wire and connect to negative terminal of function generator. This is connected to ground. So let us take the bottom first row as a ground in the breadboard. I will connect to a ground. Capacitor other end is connected to the diode N terminal. So I will take a diode. This is the N terminal of a diode, which is silver color ring is there, that side. So I will take this N terminal of a diode, connect to a capacitor in a breadboard. So that capacitor is connected to the diode N terminal, and I will connect P terminal of a diode in some other point in a breadboard. Now P terminal of a diode is connected to positive terminal of a DC power supply. So I will take one wire, connect to P terminal of a diode, which is connected to positive terminal of a DC power supply. So here is a DC power supply. This I am connected to a positive terminal of a DC power supply. Yes. Now diode P is connected to the positive terminal of DC power supply. Negative terminal of a DC power supply is connected to ground. Take a wire, and connect to a negative terminal of DC power supply. This negative is connected to the ground. So this row is a ground line. So I will connect to a ground. Next 200 kilo ohm resistor is connected in a circuit. One end of the resistor is connected to the N terminal of a diode. So I will take a resistor, and this point is the N terminal of a diode. I will connect to N terminal of the diode, and other end of the resistor is connected to the ground. So I will connect this to ground through some intermediate point. Let us connect, because this terminal is not enough size so that I can connect directly to ground. I will connect in some point in a breadboard, and I will take one wire, take this point, connect to the ground line. So this is connected to a ground. This row is a ground line. Connect to a ground. If you see the resistor one end is connected to the N terminal of a diode, another end is connected to the ground. Now we will connect a digital oscilloscope to the circuit. So digital oscilloscope has channel 1 and channel 2. One channel, that is channel 1, I will connect to input, and channel 2 I will connect to a output. So take a probe. This is a probe. Connect to a channel 1, this, and this is the first probe, probe 1, which has a positive. This end is positive and this end is negative. So I want to connect this to a input voltage, that is the voltage coming from a function generator. So I will take a wire, connect to a positive terminal of this probe, which is connected to the positive terminal of a input voltage. So this is the positive terminal of input voltage. This is the positive terminal of a channel 1 probe. I will connect it here in a breadboard. We will connect to the same point where positive of the function generator is connected, and this is a negative terminal of a probe, so which I will connect to the negative terminal of a input voltage. We will take a wire, connect to the negative terminal of the probe, which is connected to the negative terminal of the function generator. This is the negative terminal of this function generator, which is connected to a ground. So I will connect this also to a ground. This complete row is a ground line, so I will connect here. Now channel 1 is connected to the input positive and input negative. Now we will take one more probe, second probe, which is connected to channel 2. Again this probe has two terminals, one is positive, this terminal, one more is negative. According to the circuit diagram, the output is measured across the resistor. So I will connect the positive of the probe to the resistor one end or N terminal of a diode in a breadboard. So this positive of the probe I am connecting to the N terminal of a diode or a resistor one end according to the given circuit, and negative of the probe is connected to the another end of a resistor or which is a ground terminal. So another end of the resistor which is going to ground is this point. So this complete row is a ground line. I will connect this to a ground. Now we have done a complete connection for a positive clamping circuit. Now turn on the function generator using a power button, and similarly turn on the DC dual power supply. Before turning on this dual power supply, keep voltage to a minimum value and set current to a maximum value and turn on this. Now we will turn on the digital oscilloscope. For this experiment we need a square wave as an input that we have to set in a function generator. So I need a square wave, press on a square button. I need a square wave having a frequency of 1 kilohertz. So I will set a frequency of this square wave signal as 1 kilohertz by pressing this button. So I need 1 kilohertz, so I will type 1 and press on a kilohertz. Now this function generator is giving a square wave signal with 1 kilohertz frequency, and I need a amplitude of 8 volt peak to peak. So I will set a amplitude by pressing this button. I need 8 volt, so I will press on 8 VPP, 8 volt peak to peak. I have set a square wave having a frequency of 1 kilohertz and amplitude of 8 volt peak to peak. Now a square wave is ready with a frequency of 1 kilohertz and 8 volt peak to peak amplitude. I will on this signal so that it can go to the circuit, and this is DC dual power supply. I need a DC dual power supply or a DC voltage value of 2 volt. So I will set this as 2 volt by using a voltage knob. So I will vary this voltage and I will set it to 2 volts. Now input is ready and power supply I made a 2 volt reference voltage. Now we will come to the digital oscilloscope. There we can observe input waveform as well as output waveform. So whenever we turn on the digital oscilloscope, first go to default setup, wait for some time, then go to auto set. Now we can observe two waveforms in the oscilloscope display. One is with a yellow color, one more with the light blue color. The yellow color signal is the channel 1 signal which we have connected to a input. So yellow signal is a input voltage, and light blue color signal is a channel 2 signal which we have connected to a output voltage. So light blue is a output voltage. So I will move this input voltage and output voltage to a reference line in the display by using this vertical position. Channel 1 signal I am moving down so that I can merge channel 1 reference line with the reference line of a display. Similarly, I will move channel 2 pointer to a reference line. Now input waveform and output waveforms have merged together. So if I want to see only input of the output by pressing button 2, now this is the input waveform which is a square waveform. The input voltage has 1 kilohertz frequency which already we have set it in a function generator, and its amplitude is 8 volt peak to peak, that is above the reference line 4 volt and below the reference line 4 volt, that is plus 4 volt minus 4 volt. For this input we will observe the corresponding output voltage which is available at channel 2. So this is output waveform. So I will zoom it so that I can clearly observe the clamping level. And if you see this output waveform, this waveform exists only above the reference line, that is which is exists only the positive region. So this is called a positive clamper output. And if you see this line, if you see this point here, this point is shifting by a 2 volt from a 0 line. Here this line is touching to the second small division, each small division having a value of 0.2. So 2 small division is covering, so it is a 0.4. If I multiply this 0.4 into the channel 2 scale which is 5 volt, 0.4 into 5 is 2 volt. That indicates that the lower end of the signal is starting from a plus 2 volt, and we will see the upper end of the square wave which is touching to this point. If I measure a distance from this 0th line to this point, it is covering 2 blocks, each block having a voltage of 5 volt. So if I multiply this 2 block into 5, it will be a 10 volt. So I will note down these readings as a positive clamping level which is plus 10 volt. Now we have done with the positive clamping circuit and observed the positive clamper output and also noted down the positive clamping level. Now we will begin with the negative clamping circuit connections based on the given circuit diagram. Already we have a circuit connection for a positive clamping circuit. If we compare a circuit diagram of positive clamping circuit and negative clamping circuit, there is a small difference, that is diode orientation has been reversed and DC power supply terminals has been reversed. So I will do the corresponding changes. So to make corresponding changes, I will turn off DC dual power supply, and diode I will just reverse the diode, remove the diode, and I will reverse the diode orientation and reconnect the diode in the same place, and also I will change the voltage source, that is DC power supply terminals. I will connect positive to the ground and negative to the N side of a diode. So just I will reverse positive, I will interchange positive terminal and negative terminal. Now this is the circuit connection for a negative clamping circuit. Now already we have set the input for a positive clamping circuit. Same input we will keep it, we won't change any input. That is a square wave with a frequency of 1 kHz and amplitude of 8 volt peak to peak. Now turn on the DC power supply. Before turning on, make voltage to a minimum value and current to a maximum value. Turn on it and set DC voltage as 2 volt by using a voltage knob. And now come to digital oscilloscope. Again we will go to auto set, wait for some time. Now again we are getting a two signals, one is input, one is output, same like last time. Yellow color is a input signal, light blue color is a output signal. We will bring both signal to a reference line by using this vertical position knob. Similarly channel 2 I will move it up and I will bring it to a reference line. Now we have merged input signal and output signal. So off the output signal by pressing button 2. This is a input signal which is a square wave having a frequency of 1 kHz and amplitude of 8 volt peak to peak, that is positive 4 volt and negative 4 volt. For this input we will observe the corresponding output. I will off the input by pressing button 1 and I will on the output by pressing button 2. So this is the output. So I will zoom it by using this scale, amplitude scale knob. I will turn it. Now this is the output what we are getting, and if you see this output waveform is exists only below the reference line or below the zero line, that is a negative signal. This indicates it is a negative clamper circuit. And if you see this line which is not touching to 0, from 0 to this line there is a 2 small division. So each small division value is 0.2. So 2 small division is nothing but 0.4. 0.4 into 5 volt, that is 2 volt. So the signal is starting from minus 2 volt, and if you see the negative peak voltage which is covering almost 2 blocks into 5 volt, that is 10 volt. So this negative clamping voltage level is minus 10 volt, which we will note down. We have finished with the negative clamping circuit connections and observed the negative clamper output waveform and noted down the negative clamping voltage level.
At MSR UAS, we spark your imagination unlike any other.